When most people think of fuel, they think gas stations or oil rigs. But what if the most promising energy sources is actually something microscopic and bright green? In this video, I'm exploring algae biofuel, how it's grown, how it becomes fuel, and why it might be a major part of our renewable energy future. Algae is cultivated in two main ways: open ponds and closed photobioreactors. In open ponds, algae is grown in large, shallow pools exposed to sunlight. In photobioreactors, the algae grows inside clear tubes or tanks where light, CO2, and nutrients are carefully controlled. Because algae performs photosynthesis, it captures carbon dioxide directly from the atmosphere, or even from industrial exhaust streams, turning it into a biomass. Once the algae is grown, it undergoes harvesting and extraction. First, the algae cells are collected and dried. Then the lipids, the oils inside the cells, are extracted. These oils are converted into biodiesel through a chemical reaction called transesterification. Some strains of algae also produce carbohydrates that can be processed through fermentation, producing ethanol. Overall, the entire system depends heavily on photosynthesis to create the biomass and on either chemical conversion or biological fermentation to convert it into usable fuel. Algae biofuel is currently in the late research and early commercial development stage. A few small companies like Sapphire Energy and Algae have produced pilot-scale quantities, and algae-based jet fuel has even been tested in commercial planes. However, large-scale production is limited due to the cost and energy required to grow and harvest algae efficiently. One of the biggest benefits of algae biofuel is its low carbon footprint. During photosynthesis, algae absorbs carbon dioxide, which offsets the CO2 released when fuel is burned. Unlike fossil fuels, algae does not add ancient carbon back into the atmosphere. Some studies estimate algae fuels can reduce life cycle greenhouse gas emissions by up to 70% compared to petroleum-based fuels. Right now, algae biofuel is more expensive than regular gasoline, ranging from about $5 to $10 per gallon in small-scale production. However, if production efficiency improves and scaling becomes feasible, the industry could create thousands of jobs in agriculture, biotechnology, and engineering. Some regions with strong sunlight could even build entire algae farms as a new energy sector. Since algae biofuel is unfamiliar to the public, companies and researchers often use educational campaigns, animations, and environmental marketing to show how algae captures carbon and reduces dependence on fossil fuels. Airlines that test algae-based jet fuel also highlight it in sustainable reports to build consumer trust. Based on available data, algae biofuel has major advantages. It's renewable, carbon neutral, and high yield. The biggest challenges, however, are cost, scaling, and energy use during harvesting. I believe companies should prioritize research into more efficient algae strains and better harvesting technologies, such as magnetic separation or cheaper drying methods. If funding were unlimited, I would build multiple large-scale pilot facilities combining photobioreactors with industrial CO2 capture systems. I would also invest heavily in genetic engineering to create algae strains with higher oil content and faster growth rates. Finally, I'd launch public outreach to educate consumers and industries about biofuels, focusing especially on airlines, trucking, and the military, sectors that cannot easily switch to electric power. These are the sources I used, and thank you so much for watching.